You'll need plenty of space to work through problem number 20. There is more than one way to do this problem and still get the same answer. I'm going to start by moving the 2 to the opposite side just so I don't have to work with a negative. Not required, just my preference. I'm also going to write them in rational exponent form. So the 2 comes over, it becomes positive. So in this step, all I've done is I moved 2 to the opposite side. When it crosses over the equal sign, it becomes positive. And I've wrote both of the radical signs in rational exponent form. Now my goal is to get rid of or eliminate the exponents. So I'm going to raise both sides to the second power. On the right-hand side, the 1/2 and the 2 cancel, becoming ones, and I bring down 4x minus 3. Because these two quantities inside your brackets are separated by a plus or minus sign, in this case plus, I can't just distribute the square to the front portion and the back portion. In fact, I have to write this entire thing twice. On the right-hand side, I'm going to FOIL, multiplying the front. So this is often the most difficult part for students, multiplying the front portions. Remember, raising something to the 1/2 is really like taking the square root. And in this unit, we learned if you have the same value, the square root of the same value, times the square root of the same value, you really bring down just one of these values. For instance, the square root of 3 times the square root of 3 is just 3. Or the square root of 7 times the square root of 7 is just 7. So the square root of this times the square root of this is simply 2x minus 5, taking care of the front. Multiplying the outsides. That would be positive 2 times this quantity. So I'm going to push them together. 2 times the quantity, 2x minus 5 to the 1/2. Similarly, when I multiply the insides, again it's a positive 2 times this quantity. And the last one is the easiest. 2 times 2 is 4. So I'm going to move over and then combine like terms. For instance, the only term here that has just an x and no exponents other than a 1 would be this one. And when I take a 2x and I move it over, I'm going to subtract 2x from both sides. Then I'm going to combine negative 5 and positive 4. And negative 5 and positive 4 combine to give you a negative 1. But when I move a negative 1 over, really I'm going to add 1. Negative 3 and positive 1 is a negative 2. So I've moved over 2x, negative 5, and positive 4. Notice I have two groups of the exact same thing. 2 times this quantity plus 2 times this quantity is really a positive 4 times this quantity. Our ultimate goal is to solve for x. I'm going to divide both sides by 4. The 4's cancel. And I'm going to do what I call the heart method here. 2 divided by 4 is a positive, reduces to 1/2 with an x. Negative 2 divided by 4 is a negative 2/4, which reduces to a negative 1/2. Next, we want to get rid of this 1/2. And so we're going to raise both sides to the reciprocal of 1/2, which is 2. On the right-hand side, 1/2 and 2 are going to cancel, really turning into a 1. And because we have a plus or minus between these two quantities, I can't simply distribute the square. I need to write this whole thing twice. Let me rewrite this a little bit neater. I'm going to do it over here. On the left, I'm going to FOIL, and it looks much more difficult than it is. And if you struggle with multiplying fractions, feel free to use a graphing calculator and use parentheses when you plug in the fraction. So I'm going to start with F4 front. 1/2 times 1/2. So how do I do this? 1 times 1 is 1. 2 times 2 is 4. And there's 2 x's. Done with the F for FOIL. Now I'm going to go to the outside, so I'm looking at this value and this value. Don't forget about the negative here in front. 1 times -1 is -1. 2 times 2 is 4, and there's 1x. Going on to the I, -1/2 times +1/2 x. -1 times 1 is -1. 2 times 2 is 4. And there's 1x. Okay, L for last. -1/2 times -1/2. -1 times -1 is a +1. And 2 times 2 is 4. We're going to let the calculator now do the harder work. So I want to combine like terms all on one side. That means I want to take this 2x and move it to the opposite side. And I want to take this -5 and move it to the opposite side. In both cases, I'm changing the signs, and I have nothing remaining on the right. Okay, so when I look, I have 1, 2, 3, 4, 5, 6. I have 6 terms. We're going to combine like terms. The only term out of these 6 that contains an x squared is 1/4. So 1/4 x squared. There is 3 terms that have simply an x. And if you don't mind combining them in your head or on paper, feel free to do that. I'm going to use the calculator. So in parentheses, I'm going to type in -1/4 plus -1/4 plus -2. -1/4 plus -1/4 plus -2. I'm going to press enter, and I'm going to turn it back into the fraction, hitting math, fraction, enter, enter. -5/2. Remember, it contains an x. Finally, the last thing. So I've taken care of the x squared, the 3 that have x. Now these are the ones, the constants, that have no x's. I'm going to do 1/4 in parentheses plus 5. 1 divided by 4 plus 5. Turn it back into a fraction. 21/4. Now let's go back to what we learned at the end of last semester. We learned that when we have all these fractions, there's an easier way to solve. And that is, let's find a common denominator. Once that's found, we can wipe out the denominators. So 4, 2, 4, 1. A good common denominator is 4 times 4 times 4 times 2 times 2. So 4s, 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 and 4s, I wipe out. And now on top, I have 1x squared minus 10x plus 21 equals 0. Is that factorable? Can you think of 2 numbers that multiply to equal positive 21 and combine to equal negative 10? And we can. Those numbers would be -7 and -3. Solving would be x equals 7 and x equals 3. Okay, we have to check for extraneous solutions. I'm going to start with the 7. 4 times 7 is 28. 28 minus 3 is 25. Well, the square root of 25 is 5. 5 minus 2. Okay, going to 7 again. 2 times 7 is 14. 14 minus 5 is 9, and the square root of 9 is 3. Does 5 minus 2 equal 3? It does. That means the 7 works. Let's check 3 next. 4 times 3 is 12. 12 minus 3 is 9. The square root of 9 is 3. And 3 minus 2. Okay. Remember, we're checking 3. 2 times 3 is 6. 6 minus 5 is 1, and the square root of 1 is 1. Does 3 minus 2 equal 1? It sure does.